Right, good evening. So this is a little bit of an experiment. I am using I have to move the mic over here. So the mic's all set up now. So I'm not going to do testing 1 2 3 because that's really tacky. Anyway, yeah, talking about vapor pressure, I have posted something in the group, and you're probably thinking, what's this crazy man on about? So what I'm going to do is explain what vapor pressure is as quickly as possible. Basically, and there will be some people that will how can I say, correct me on certain things, but basically we're at 1 bar atmospheric pressure, okay, because we're above the surface, which actually it's not. It is 0.79 bar because that is the pressure of the nitrogen that we live in, or which it makes up most of the air, so that dominates the pressure that we get. So when it comes to construction, and you know, when you have a floor replaced in an apartment or in an extension and things like that, you have the floor replaced, and then you have the pressure of the water pushing up from the ground. Now, if it's, say, clay, for instance, clay is made up of loads of different particles, which are, I suppose you could say, ancient organic stuff, which has got different platelets in there. So therefore, when it gets wet, water expands and these platelets expand and contract. Loamy soils are completely different as well because they're made up of more organic material which hasn't rotted down. So they expand or drain at a slower rate. So, right, that out of the way. When you have a floor done in a property, for instance, and I had one done a few years ago and it's fine, the detailing is the important thing that you have to bear in mind. So I've got a model here for you, and well, it's a bit of cardboard basically, and also I've got a drawing that I'm going to flip to do the camera to show you. So I'm doing two things at the same time, if you know what I mean. So when you have a floor replaced traditionally, right, and I forgot to flip the screen over to the other way, so this is right and left, so you have to bear with me. You have, this is the concrete, this is they call it the substrate, the posh word is, that's the dirt, right? Then you have a layer of sand, then you have insulation, then you have another layer of what's known as damp proof membrane, DPC, damp proof membrane, damper of course, DPC, right? So you have another layer of basically visqueen which goes on top, and then you have, say, your screen on top of that, or you'd have your concrete, then you'd have your screed, and then concrete, visqueen, visqueen. Oh mate, I'm going to start this one again, right? No, I'm not. Anyway, so basically, you have your insulation, then you have your concrete slab on top, and then you have your screed. But you'd have visqueen somewhere in the mix, right? So the main thing is this is the visqueen, and this is going to be more professional when I do it on YouTube, by the way, right? So as that is done, right, and you can imagine that this is the all of the stuff that you've poured in, and they've got this visqueen that comes up to that way. The visqueen comes up, and then it is like that, right? I'm going to get some fancy drawings done at some stage. So what happens is the water vapor, or the pressure from the water vapor, there we go, comes up the back and goes behind the plaster, and that's why you get rising damp, right? So what they should do is they should get that and tuck it into the brickwork course, so that basically it comes under the DPC. That's it, because this is a damp-proof membrane. Got it? Right? So anyway, that comes under the damp-proof course that you've got, and then the water will then come up and it'll be trapped under here, and then it won't come into the property. But they tend to do it that way. So what happens is the water comes up the back of here, and then comes into the property, and that's where you get the problems, and that's why people are getting problems with slab floors which are being poured because of that small detail. Now that isn't the end of it, right? Because if you can imagine, when you come to a corner, you've got to go this way and that way. So what happens is, or what you can do, is you think, well, that's a simple fix. I will just, let me just do that. There we go. So now you have two breaks, yeah? So, but as you can see, that is basically going around the corner 90 degrees, whatever that angle is, but you still have a gap there. Yeah, you have a gap there. So the water vapor, or the pressure from the water, is going to come up through that gap there, and it's going to cause a problem in the corner. So I haven't got the solution for this, and I'm sure there's research out there that's been done to try and remedy this situation. The other problem is, once you fold that, like we've got there, you've still got this bit at the bottom, haven't you? So what happens is they cut the visqueen, and I've seen that done, right? And then they fold it up like that. Now some people will say, yeah, but my builders don't do that and everything else. But are you actually there when they do that and they do a nice little tuck? Hope the camera can focus on that. There we go. So they do a nice little tuck like that, right? So you've got the tuck in the corner at the bottom, and you've got a tuck at the top there. But I'm not going to fold it over because I've only got one pair of hands. So it's not really a solution. So that's what that's what I'm talking about when it comes to the water vapor pressure. It finds weaknesses in that bottom joint there, and come on camera, focus. It finds weaknesses at the top. So when you discuss this with your builder, try and get a plausible answer out of them. And if they say they're going to tuck this bit here into the brickwork course, really what I would say they should do is go around with the laser measurer and go around with a still saw. Maybe that's not the best idea, but get into the course anyway, into the course where the damp proof course is, and chase it out, and then tuck this in at least half an inch, and then use some sort of mastic to seal the top there. So you've got a bead across the top, which is going to stop the water vapor from coming up the back and then coming into the property. So that needs to be addressed. So that's it. I'm just going to do a little drawing, and then well, I've got a drawing here actually, but I want to use this little funky camera that I've got now. I've got a new rig over here, which is a top-down rig that I'm going to be using to experiment with. So I'm going to experiment with you lot. So I'm just going to change the camera so you can see it, and then I'll go over the old thing again. So just bear with me while we switch over. Come on, camera. So let's have a look. If anybody knows of any software that I can use to do this, by the way, then by all means give me a shout, because it would be quite interesting to know how to use it. Come on. No, it's not going to work, so I'm going to stop this, and then I'm going to do the camera, then I'm going to send you the drawing, just because I can. All right, bye for now.